Hello everyone, welcome to my presentation on the Diploma in Machine Learning with Python. My name is Ugwal Richard, a student at Makerere University pursuing Bachelor of Science in Software Engineering. I will be sharing the key knowledge and practical skill that I was able to gain from the completion of this course on Allison. Through this presentation, I'm very sure that I will introduce the fundamental concept of machine learning and also at the same time exploring the important algorithm and techniques implemented using Python, and also discussing how these methods are applied to solving real-world problems in the field like data science, machine learning, and other related ones. So therefore, allow me go to the next slide and we get started. The next slide is all about the introduction to this concept, that is machine learning. We all know that machine learning is a branch of artificial intelligence that enables the computer or the system to learn from the data and make the prediction or the informed decision without being explicitly programmed for every task. Therefore, I can say the goal of machine learning is just to make a model or a system that is going to give us the informed decision or the predicted outcomes based on the available data. So let's dive into type of machine learning. We have three core type of machine learning. The first type is supervised learning. The second one is unsupervised learning. The last one is reinforcement learning. We shall look into length into the next slide, the core details of this type of machine learning. So the first type is supervised learning. Supervised learning is just simply means training the models or making the machine learn on the label dataset. To give us the unseen data or outcomes. Supervised learning, generally we can say it the model learn by mapping the inputs and outputs so that it can predict for us this unseen data. Take for instance in some other use cases like spam detection, where in an email system, the system is able to categorize using its model, its AI model. This is a spam emails or message, and this is not a spam one. Then it puts in the right place where they're supposed to be. That is under supervised learning. That model is being trained in a supervised way. That is what I can say about that. I think that is clear. Then let's go to the second type, that is unsupervised learning. Unsupervised learning, for this case, it uses unlabeled data, that is to find the hidden pattern in the dataset. Let's take for instance in clustering, that is maybe grouping similar data points so that we can really find clear patterns in between them or amidst them. The third type of machine learning, that is reinforcement learning. This is the one where the model learns by interacting with the environment. The goal is to maximize the total reward. Let's take for instance in use cases like robotics. I think the typical example is self-driving cars, where the cars are able to drive themselves independent without having human being controlling anything. You find like the car is able to send a signal to the environment and give the information. The information is now the action that the car is going to execute. What the camera is sensing, there's no human being, then it moves in that pattern. Maybe it moves in that particular space, maybe in parking. So that is what machine reinforcement learning is all about. So the model learns by interacting with the environment. I think that is the brief description about these three types of machine learning. Let's go to the next slide, then we'll see what it is all about. The next slide is about feature scaling and data scaling, and data cleaning rather. Basically, feature scaling for this case is a crucial pre-processing step in many machine learning algorithm, and it's actually something very, very crucial because it ensures that all features or variables in the dataset that we are using are maybe like a scale, for instance, like similar data as scale, and at the same time while preventing algorithm from being biased. We don't want our algorithm to be biased maybe on a certain features within the larger numerical range. That is what feature scaling is all about. Yeah. So we have the data cleaning. Data cleaning just simply means we have to clean the data, removing unwanted variables. Maybe like removing incorrect, corrupted format or duplicate in our data set, so that we have the clean data within the data set. You know, like when the data set is very clean, it can help a model to also make a better performance. Yeah. So we also have some other techniques within this feature scaling. We have handling missing data, that is like maybe removal of missing values. Then we have another one, removing duplicates, identifying those data which are repeated in the data set so that we can clearly have a clean data set, correcting errors, maybe like rectifying incorrect formatting, identifying outliers. Those are processes of cleaning the data set so that we can use a clean data set. Yeah. So a quick reminder, when the data set is clean, the model can give us the better performance or the better outcomes. Let's go to the next slide. The next slide is still all about feature scaling. That is normalization. Normalization is just all about the process of scaling the data into a specific range, usually between 0 and 1. Yeah, normalization is actually something very crucial, as it ensures that no features dominate others in a distance-based algorithm. Yeah, like k-nearest neighbor. Yeah, that is basically what normalization is all about. It's a part of feature scaling. Then we have another concept within feature scaling. We have standardization. Standardization is just all about scaling our data within the data set so that it has a mean of 0 and standard deviation of 1. Remember, these are some of the concepts that can help us make us have a data set that can make our machine give us the better prediction or effective one. Yeah, or the outcomes, I can say like outcomes. Let's go to the next slide. The next slide outlines the future engineering. Feature engineering is also the process of using the domain knowledge to extract features from the raw data to improve the model performance. Yeah, basically, feature engineering, the main goal of this concept is to improve model performance of machine learning. Yeah, so a good future, remember, it leads to better predictive performance. We have some of the common techniques of future engineering. We have one odd coding, one odd con no, I mean one odd coding, one odd encoding rather. It's just about it was slip of tongue. I'm sorry for that. It's just all about converting categorical data into numerical value, usually between 1 and 0, usually 1 and 0 rather, so that the algorithm can process effectively. Remember, categorical data gives a better prediction. The model works well with categorical data. Yeah, so the main aim of one odd encoding is to convert this categorical data into numerical values. It's just about refining this categorical data. That's why I'm saying like it works best using that. Yeah, it's a refined version of categorical data give a better prediction. For example, converting colors like red, blue into numerical values is one of them. Let's come to another common techniques, that is binding. Binding is just grouping continuous data into discrete categories. For example, age, teen, adult, senior. Yeah, that is binding. Then feature creation, combine existing to create new or more features. For example, like you can relate from a formula, maybe like speed is equal to distance out of time. This can give the model a clear way to find a possible outcomes on the pattern maybe the model is working on. Yeah, so therefore feature engineering is something very crucial. Let's go to the next slide. Linear, sorry, I'm running out of power. That is linear and versus logistic regression. Linear regressions, the purpose is to predict continuous outcomes. Yeah, the purpose of it is to predict continuous outcomes. For example, of linear regression, we can say maybe like house price predictions, where maybe the model predict the outcome based on maybe like the input such as the size of the room, the location. That is the one we call linear regressions, and that yeah. Then we have stock market trend. The model use the continuous inputs like maybe uh, the current the current market trend. So within the stock, people who do forex trading always use linear regression. Then the second one, let's come to logistic regressions, used for binary classification task. And it's used for binary classification tasks. So to give us outcomes, for example, maybe in email and spam detection, and also like at the same time maybe medical diagnosis, where a model gives the possible outcomes based on uh, the inputs such as maybe like the treatment pattern. It compares with the existing disease level and the current one and the previous one, so that it now conclude like maybe the patient is responding to the medical treatment. So that's about logistic regression. Let's go to the next slide. Um, the next slide is about regressions and correlation method. Um, Correlation, it measures the strength and direction of the relationship between two variables. Actually, relation is just give us uh, the relationship between variables. For example, like a -1, +1. That's a negative meaning like a perfect negative relation between two existing variables. We just want to compare how strong that strongness in the relationship. It does not guarantee that maybe like maybe a strong correlation maybe cause the other variable. We are just comparing the relationship between them. So it is very important for us to know how variables are related to one another. Then we have, let me go to another slide, that is the k nearest neighbor, that is in model 2. K nearest neighbor is a supervised learning algorithm used for classifying the regressive, used for classification rather, and regressions. How it works, it defines the k closest data point, assign the majority class, and identifying the matrix, that is now the distant metric. Usually we use Euclidean distance to find the closest one to the data point. Yeah. So another models, we come to model 3, that is the tree, the decision tree. Decision tree, it is a supervised learning model that use both classification and regressions. How it works, it split data set into branches based on features and values. Each split help make decision about the final outcomes. It has some of the concept that is self-explanatory. I'm not going to into length. Let's go to model 4. That is, I was able to do some course assessment based on the previous model 1 and model up to model 3, and the performance was highly good. Let me go to model 5, that is ensemble learning. This is a technique that combines multiple models to improve the overall performance. That is now combining all models so that we can have maybe like one unique performance, then we see the outcomes. Yeah. So the key benefit, it reduces overfitting, improve accuracy. That is very true. When you combine very many models together, their performance is going to increase. Then and accuracy at the same time, reduce variance and bias. Then main type of ensemble learning, we have bragging, that is train model on random data set of the data. Then boosting, model learns from previous error. Then stacking, train multiple model, then combining their prediction. Let's go to random forest. It's an assemble method made up of multiple decision trees. Yeah, this is also self-explanatory. Everything is into details, brief, and very concise. We have model 6, that is support vector. Support vector machine, that is a supervised learning algorithm used for classification and regressions. Application, we have text classification, image recognition. That is what I was able to learn, and it's actually very crucial in machine learning. We have principal component analysis, a techniques for techniques for dimensionality reduction that transform features into new and uncorrelated variables called principal component. Yes, it was also one of the core concepts in machine learning that I was also able to learn. Basically, it works by identifying the direction that captures the most variant in the dataset, project the original data into this component. The main key importance of this rather is to reduce the dataset complexity and computational costs, helping visualize high-dimensional data and improve model performance by reducing redundant features. We have application of this principal component analysis, maybe like reducing in reduction of large data set, we want to reduce the size, not the quantity. We want to reduce the size of the data set so that we have fewer variables, which can be helpful in enhancing model performance. We're just reducing the size of data, but no, we are not losing the data information within the data set. Then data visualization, noise reduction, feature extraction, and image processing. That's the application. We have the second course assignment that I was able to do. That was really very nice, accessing my performance within those previous modules. So it was something I was able to do and was really very nice. Then the learning goal, this assessment was very good to me. It actually has equipped me with a deep insight of machine learning. Then the course wrap up, I was able to learn all the key concepts in machine learning, the core one, and also do some little programming for coming up with a simple model based on the concept that I was able to gain from this. Then the best practice learned from this course assessment, I was able to clearly identify that if you want to come up with the best model which performs and give a very good prediction, you have to have a clean data set. You have to scale this data set to handle the specific objective. Then you have to engineer the features for better performance and then evaluate model performance using the correct metrics. Final assessment was the one I was able to do. It was out of 60. That was like the end of all the assessment, which was combining from module 1 up to the last module. Yeah. Thank you so much for this moment. I appreciate as we dive into this career to build the better machine models that can really help in solving real world problem. I therefore would love to stop here as my presentation ends here.